Welcome to this training video. In this training video, I will show you some object-oriented design principles. I will not explain the different object-oriented programming concepts, but it will be on the side of design, object-oriented software development. When you do object-oriented software development, what are the different design principles when you define the classes or objects, what principles they should maintain. Anyway, this is Said. I provide consultancy under Just Etc. Technologies. Here I provide training videos. You can ask any questions here. Okay, so these are some design principles for object-oriented software development. The first principle: minimize the accessibility of classes and members. So what it is telling is you should not expose the classes to others unnecessarily. You should not expose the members of classes to others unnecessarily. So just to restrict the accessibility of classes and its members. Actually, by doing this, we ensure two of the basic object-oriented principles like abstraction and encapsulation. By providing this, we provide more abstraction and we encapsulate. And I think by providing abstraction, we provide the programmer to handle the complexity easily. Because if we don't expose classes unnecessarily to others or the class members to others, then when the programmers will be writing the code, they will not think about the unnecessary details of the implementation or how the class or object internally works. They don't have to consider those. They can just know the object superficially or from the outside view and can work with that. And another thing is, let's say by inheritance we also expose classes to its subclass. So sometimes it may also not be a very great idea. It can also have some side effects. So we also have to be careful when we are creating subclasses or when we are using the inheritance concept. Inheritance providing the polymorphism, but it also is creating some side effects. So we have to be careful when we are creating subclasses. Favor composition over inheritance. So what it is telling, we should prefer composition in general more than inheritance. In composition, you know that one object or one class can contain other classes or objects as its internal members. So that is composition. Composition is kind of has a relationship. And inheritance, you know that you can inherit another class, another base class, and you become the subclass. So you just extend the properties and methods of the base class. So in general, there is an assumption that or in the early days of object-oriented development, inheritance was overused. But over the time, we have experienced that composition in many cases performs significantly better than inheritance. Inheritance has some disadvantages. It exposes classes to the subclass. And the third principle is program to an interface, not an implementation. What it is telling that when you are defining some data types, and for the data type, we can use the interface for the data type. Then if you are telling that we are trying to declare an object of X type, if X implements another interface, then we really should not use X, but we should really use the other type. Yeah, not an implementation. This is also true when you are passing parameters. Yeah, when you are passing parameters in the parameter section function parameter, you can use the interface type, not the implementation type. A practical example can be, let's say, you can write list my list equals to new array list. So list my list, here you are using list interface to declare the my list variable. But you could also write array list my list equals to new array list. Here we are using array list to define the my list object, but this array list is an implementation of list interface. So this principle is telling we should use the list interface to create the my list variable. It provides you flexibility, and it provides you to deal with all the other interfaces that are based on the list. And if at one point you, after writing lots of code, if you decide that you want to use tree list, then changing this one line may work when you will be using the list interface. But if you use the array list, then you have to change more. Open closed principle. This principle tells you should write the classes or modules in such a way so that you don't need to change it for the new requirements. But for the new requirements, yes, if you need it for extension, you can extend it, but you should not modify it. Software entities should be open for extension and yet closed for modification. We'll see the details later. Okay, the single choice principle, SCP. It is an extension or corollary to this open closed principle. What it is telling that when you have to support a set of alternatives, so this set of alternatives should go to another class that will contain all the alternatives. Let's see, if in some classes or in some software system you need to calculate the prices, so you can keep the price object, price method here and there related to the classes or whatever. But if the price changes out of some policies, and the pricing policy changes and price is dependent on some policies, in that case you have to change all those different objects, classes. But that's not a good thing, because you're just modifying the existing stuff. So from the beginning you could define some sort of pricing policy class, and you could place the calculating the totals or calculating the total price or getting price appropriately. You can place them appropriately so that you don't have to change here and there in all the objects or classes that tries to find the total price. I think you can design the new class or pricing policy class in such a way so that you don't need to modify the other classes as much, and pricing policy can handle it in a general context. What is this list of substitution principle? What it is telling, functions that use references to base classes must be able to use objects of derived classes without knowing it. What it is telling is, let's see, if we are using an object in different places and then you define a subclass based on this base class. Subclass, you can just, when you inherit it, extend it, you create another subclass. What it is telling, wherever you are using the base class, if you change all the places with the subclass, still the program should work exactly as it was. Okay, but it's something very difficult to maintain. So looks like if you do not inherit, extend properly, appropriately, if you do not create the subclasses appropriately, it may easily break this rule. So whenever you are extending or using inheritance, you should carefully take a look if inheriting is violating this principle or not. Yeah. Now I will explain these principles, and I will be using these lecture slides from some professor. Another thing is program to an interface. I think this topic discusses this. As I just told, this is a good way because I am using the list interface to declare my list, but this is bad. And if you go to here, I think you can also get an overall idea when interfaces are more appropriate to use or when you can use interface. Actually, what it is telling is, in general, classes, abstract classes, those are more appropriate than interfaces. But if you find a case that when for several unrelated classes or objects, you need some common properties or common methods, common functionalities. So for these common traits, you can create this interface. In PHP 5, you have some trait concept that provides this facility as well, in addition to interfaces. So you can check it, and the example program to an interface, then implementation, you can get some ideas why here. You can read other discussions or other answers. And another thing is this object-oriented analysis. So this is a short note written by myself. I think it will show you the step-by-step procedure when you are doing the object-oriented analysis or object-oriented design. And it also incorporates how to use UML at different points of the object-oriented analysis and how different UML diagrams can help you in object-oriented analysis. So just taking some time. So by the time it comes, we can take a look. Okay, I think this is the okay. So this is the slides for another professor. I will use this to explain these principles more. So here is the object-oriented analysis, just an overview. So it is just defining the steps and all of the different UML diagrams can be used and how the object-oriented design should work. Anyway, so the first principle, minimize the accessibility of classes and members. So what we are telling, we should not expose the classes and its members to other parts of the software unnecessarily. It is primarily about the members. In some cases, classes, it also, I think we can also consider that by reducing the inheritance or extended unnecessarily, we are not exposing classes to subclasses. I have to check if this also belongs to this principle. It may be only belongs to the members. Okay, what does abstraction means? Before telling this, let's see, this principle is about providing abstraction and encapsulation. And by providing encapsulation, we are actually providing abstraction. And in object-oriented programming, I think the design concept is the programmer should deal with the objects and with their external behaviors. They should not be dealing with or thinking all the time what is happening internally or inside, how the objects are working internally. So by removing the user from the thought of internal world, the programmer can handle the programming or the development more easily. So it reduces the complexity and programmers don't have to deal with the internals and don't have to think on that. So it will make his life easier. Okay, abstraction focuses on the outside view of an object and separates an object's behavior from its implementation. So the programmers will not worry about how it is implemented internally, just view the outside object and work with its behavior and interactions with other objects, and focus on writing the activities in the interactions in the software. So you have to define the objects or classes in a very good way. Encapsulation. By providing encapsulation, we are actually providing the abstraction. So what does encapsulation? Encapsulation is a mechanism to hide the data, internal structure, and implementation details of an object, hiding the properties, internal data, internal structure, and how they work. Programmers don't need to worry about this. So we have to encapsulate all those things. But all interaction with the object, that will be through a public interface of all operations. So classes should be opaque. Classes should be not visible from the outside, just external interface that will be visible. Classes should not expose their internal implementation details. Classes should not expose their internal implementation details. That is the principle. So this is an example of first principle. Let's see, we could write this as a properties of a class, but instead we can declare this variable as a properties as a private instead of public, and we can use two public interface, public method to access this, just to change the value of this and to get this value of it and to change it. Okay, what are the advantages of this? With these things, maybe if we want to apply some sort of constraint, some condition in set speed, we can just set it in one place. But if we would be allowing to access the speed variable from outside this class, programmers would have to write this condition in all the places wherever it uses this set speed, wherever it uses that property, this speed property. So programmers had to deal with the internals, how it works, all those things. But by keeping it private and exposing these methods, set speed and get speed, programmers don't need to worry about how this set speed works or what are the stuff internally in the set speed. But when writing this code, probably they have to consider all the different cases or situations, and then they have to write the object appropriately. And when they are done with the objects, they should be read about the thought how the object works. And using this, let's see, we can, under set speed method, we can write some sort of side effects. Okay, side effects related to set speed. We can define it as part of set speed. So from all the places, it will work. But if we do not do it like this, if we just allow to directly change the speed, directly access the speed variable speed property, then we'll have to call this notify observers or some other methods to make this happen. So programmers would have to think more, and that increases the complexity of programming, and it also increases the complexity and organization of the code. Principle number 2, favor composition over inheritance. আমরা বললাম যে compositionটাকে we have to prefer composition more than inheritance. Inheritance has some side effects. Okay, it breaks the first principle, encapsulation. It reduces the encapsulation. It also violates the links of principle, that this class, the subclasses can be used in all the places of this class. That one. Okay, what is composition? Composition is a method of function reuse, functionality reused by creating an object composed of other objects. That means inside an object, you can create object of another object. can create an object composed of other objects. The new functionality is obtained by delegating the functionality to another object that is being composed. Sometimes in terms of composition, the term aggregation and containment are used. Aggregation, what it is telling that one object can own the another object, or one object can be responsible for another objects. And the second object will have lifetimes of the owner of that object. As long as the owner exists, the contained object will also exist. Aggregation, it is telling that when one object has a collection of another objects, that is also called as composition and one type of aggregation. And containment, it is telling that it is a special kind of composition in which the container object contains another object in a hidden way. That means the contained object will be hidden from other objects. Other objects can access this contained object only through the container object. I think this is more appropriate in C++. Thing is containment. C++ allows composition by value or by reference. Java, it's always object references. Composition advantages. Content objects are accessed by the containing class solely through their interfaces. You cannot access them directly, you have to access them through the interfaces. This is the black box reuse because the contained object is under another object. It provides good encapsulation, fewer implementation dependencies. Each class is focused on just one task, and the composition can be defined dynamically at runtime through objects acquiring reference to other objects of the same time. I think when you use composition, it can refer to other objects dynamically of the same type. Disadvantage, you will have to create more objects in the overall system, and you have to be careful in defining interfaces to make different objects compositionable. Must be carefully defined in order to use many different objects as composition blocks. Inheritance, just extending a base class or super class. We are creating a subclass. It's also a method reuse. And inheritance is just generalization and specialization. The base class is the generalized concept and the specialization is the subclass. Advantage, implementation is easy to modify after the implementation being reused. But disadvantage, it breaks encapsulation because it has to expose its implementation details to the subclass. It's a white box reuse because the internals of the base class are exposed to the subclass. Another thing is, if we have to change the superclass, the subclasses used here and there may have to be changed. And implementations inherited from superclasses cannot be changed at runtime, but we can see that in terms of composition we can change it at runtime. Okay, here they're just trying to show some comparison between inheritance and versus composition. I think in this example, it primarily focuses that by extending or inheriting, we introduce some sort of side effects. If we are not careful enough, then extending on inheritance can introduce some side effect and can make the operations wrong. Let's see, this is a hash set we are extending it here, so we are subclassing it, we are using inheritance concept. There are some methods here, add all and all those things. You can assume that these are also in the base class. Now if we are using this add all, so we are passing an array, we are expecting to count 3, but the program will result in 6. Maybe by inheriting this we are not careful enough, so the objects are being, the elements are being called or counted twice. So I think there are ways to overcome these disadvantages, but this fragile nature of inheritance is problematic. So you can, when you are using inheritance without being careful, this type of side effect can always come in the play. So the best way to fix this is to use composition. So here this is the plus, and it will use it as a composition. I think this is the composition. Compose the hash map. I think the previous one, it was extending hash set. Here we are using a set. We are just composing a set. We are containing a set. Actually, set, it can indirectly refer to the hash set because this is programmed to an interface. This set can be any set that is implementing set interface. So hash set is also can be this. So if we write this code like this, so if we call it, it will count it appropriately. So this class is a set because it is implementing a set. It has one constructor whose argument is a set. The contained set object can be an object of any class that implements the set interface and not just a hash set. I think it is the telling about the contained object. It's a set interface type, so it can also be a hash set type. And this is very flexible and can wrap any pre-existing set object. So using this composition, we can use this, can compose any other pre-existing set object and use it internally. So there are some rules. There are 5 rules. If all these 5 rules are satisfied, only in that case we can use inheritance. Otherwise we should favor composition. What are these rules? We know that inheritance is a relationship. I think we will be creating subclasses when we think the subclass is a superclass. For example, animal can be a sub-base class, pet can be a subclass. Why? Because pet is an animal. So we can inherit, we can use inheritance, or we can use subclass when the subclass is a special kind of base class. But it should not be the case that the subclass or subobject is playing a role of the base class. In that case, we should not extend it. Let's see. Person, if that's the class and you're trying to extend it and creating 2 other classes like passenger and agents. Okay, passenger is not a special kind of person. Agent is not a person, or agent is not a special kind of person. What it is? Passenger and agents is the role of the person. So if we extend passenger and create agent, and so if we extend person and create agent and passenger, that's not a good design, or we should not use inheritance in this case. An instance of a subclass never needs to become an object of another class. What it is telling is, you are creating a subclass, but this subclass can be an object of another class. It should not happen. In the previous example, a passenger can be an agent can be a passenger. So about the time one subclass is becoming the object of another class. So that will not satisfy this rule. A subclass should extend the base class. It should not override or nullify the functionalities of the base class. It should not nullify the responsibilities of the base class or the superclass. A subclass does not extend the capabilities of what is merely a utility class. Another thing is, if the original class is some sort of role or some sort of transaction or some sort of device, in that case we can extend it or create the subclass as a special role or special transaction or special device. That is possible. So this is an example. Person, we are inheriting and creating passenger agent. Now we will see, does it comply with those 5 principles. If passenger is special kind of person, no. Is agent a special kind of person? No. But passenger and agent, there is a role played by person. So it's a fail. Never needs to transmute. So you can see that an instance of a subclass of person could change from passenger to agent passenger over time. So the subclass is becoming object of another class. So it's also failing. Extends rather than overrides or nullifies. This is pass. Does not extend the utility class. This is also pass. But this is a fail because person is not a role. So by subclassing, we are not creating any special role or any special transaction or any special device. So it is violating the 5th rule. So the above example is not a good place to use the inheritance. Here we can use composition. Okay. So this is example 2. Here we are creating an interface person role and role. This role is actually person role. Role is a type. It can be interface or base class, whatever. And then we are extending this to passenger and agent. Now you can see, does it comply with this? It is actually composition. It is composing this role and then this is extending. So this can be done inheritance, but so is passenger and agent a special kind of person role? Yes. So this is a pass. Is passenger or agent is playing a role of person role? No, they themselves are roles. So a passenger object is just a passenger object. The same is true for an agent object because there are some roles. Extends rather than is also pass. Not extend utility class. This is also pass. So in this subclassing, you can see that this is a role, this is a special role, this is another special role. So this also complies to the 5th role. We can, for role transaction or device, we can create a special role transaction or device by subclassing. So it satisfies the 5th rule. So this is a good example. So this is not a good example of inheritance because it is just a utility class. Reservation is just extending a utility class, so it's a fail. So the summary is both composition and inheritance are important methods of reuse, of code reuse. Inheritance was overused in the early days of object-oriented development. Over that time, we have learned that designs can be made more reusable and simpler by favoring composition. Of course, the available set of composable classes can be enlarged using inheritance. In this principle, here you can see that in that one. Within the problem domain, which are not here, we are actually here. So composition and inheritance work together, as you have told here. But our fundamental principle is we should prefer composition more than inheritance. Program to an interface, not an implementation. You can read this, but I actually told previously that should be sufficient. You can check the Stack Overflow discussion, that will give you more ideas. So what it is telling is the principle number 4, software entities should be open for extension yet closed for modification. So we can extend it, but we should not edit it or modify it. So what it is telling is the classes or modules we should attempt to design modules that never need to be changed. Practically it's impossible, but we should try for it. That will make our design very robust. So to extend the behavior of the system, we can add new code, but we should not modify old code. So these two parts, I think it is already told. Open for extension, the behavior of the module can be extended to meet new requirements. For new requirements, it is allowed to extend, but for new requirements, it is discouraged to modify existing code. Best if it is totally forbidden, if never never it is required to modify the existing code. So how can we do this? By providing all of this. So this is practically impossible that all of the modules will maintain this principle, but we should try to minimize the number of modules that do not satisfy it. In this open closed principle, this is the heart of the object-oriented design. If you can ensure it, it will make the overall design a very good one. Conforming to this principle yields the greatest level of reusability and maintainability. Open closed principle example. I think this is something example that maintains that conforms to the open to closed principle, OCP principle. Let's see, the requirement of the system is, or new requirement can be, the parts can be of many new different types. Okay, here I can see the part, it is coming an array of different parts, and can it calculate all the totals? It is calculating the totals of all the parts. So when we have new types of parts in future, we will not have to change this method in any way, provided that this part is an interface. So all the different parts that will implement it or extend it and create new different parts, and or if all those parts come as part of this array, so it will be able to calculate the total. So we can see the function is calculating the total price of each part in the specified array of parts. Now it is telling if the part is an interface, is a base class or an interface, and polymorphism is being used, then this class can easily accommodate new types of parts without having to be modified. So it conforms to the OCP. But if our requirement changes in this way, that there is another concept, pricing policy. So for there is some policy that for motherboard parts and memory parts, there should be a premium applied to the total price. So if the requirement changes like this, and if we change this code like this, total price is okay. Forget about the previous example, just consider this. This is a total price function. What it is doing for motherboard parts and memory parts, it is adding a premium. But what about if there is a new rule for another type of part, we have to add another premium? Then what we have to do? We have to modify this method so it is not conforming to the open closed principle. So every time the accounting department comes out with a new pricing policy, we have to modify the total price method. It is not closed for modification. Obviously, policy changes such as that mean we have to modify this code somewhere. Okay, then so let's say, so it is not conforming to the open closed principle. So what we could do, one option is, let's say, the get price. We could implement the pricing policy changes in the get price method. But what will happen that, let's say, get price is part of the parts. So for all of the parts, all of the different parts type and objects, we have to write the get price method and we have to add it here and there. But if all of the objects are already defined, then we have to modify all those different objects and classes. That is also not a very good idea. That also does not conform to the open closed principle. So let's see. This is one of the object types. We could modify the get price to add this premium. If accounting department wants, then we can add the premium in all of the objects in this way. But what happens is, if the objects are already defined, then we have to change all the get price method here and there. That is also a bad idea. So another good idea can be, we can create a price policy class and we can keep all the pricing policy related stuff there. So it is setting the pricing policy factor, how much premium to add on the get price. So for all of the changes, if accounting department changes the pricing policy or other department, we just have to consider the factors. So in this price policy, we are just implementing that alternatives. With this solution, we can dynamically set pricing policy at runtime by changing the price policy object that an existing part object refers to. Okay. I think each part object refers to a price policy object. We can dynamically set pricing policy, and then in that case, it will affect the total price. Okay. I think these alternatives could be kept in a database. That's a different thing, but we are just talking about the object-oriented design, so we'll be keeping our focus on there. And from here, we can see all the different alternatives. We are keeping it in a single place. That is the corollary of the open-closed principle, the single choice principle. Whenever a safe system must support a set of alternatives, ideally, only one class in the system knows the entire set of alternatives. Just like the pricing policy can handle all the alternatives. So you can see the fifth principle. Wherever you have used the base class, you should be able to use the subclass, and the program should act appropriately. But inheritance many times causes this principle to be violated. Let's say in this case, draw shape S. If we have some code here, so this principle is telling all the subclasses that will extend this shape shape, interface, or base class, whatever. If we pass all those objects here, this code should work appropriately. That is what we have to maintain. But sometimes inheritance can, if we write the inheritance or use subclasses, if we are not careful, it can get violated. Let's see, we are creating a rectangle object and we thought that okay, we need another square object. From mathematics we know that a square is a rectangle. So we can extend rectangle and use the square class. We can use this. So what it is telling, so any function that is taking a rectangle as the parameter, links of principal is telling that it should, if we pass the square object, it should also work there. But one thing, when we are designing the square class, there are something we can notice, that a square does not need a both a width and height. So this is still, a square is a rectangle in mathematics, still there is no difference. Also the set width and set height method are not really appropriate for a square. Anyway, but this is a reasonable estimate, reasonable assumption that a square is a rectangle. So the classes are implemented in that way, inheritance was done in that way. Now let's see, this is another class that is for test rectangle, so it has a method rectangle R. So if we call this method from here, test LSP R, test LSP S. So you are passing the rectangle, you are passing the square. So the rectangle area is coming all right, but the square area is not coming all right. According to LSP principle, this one is taking rectangle R, so it should strictly work if anything of rectangle type. Square is rectangle type, so it should work here, but it's not really working. So whenever inheriting, we should be careful. Just because it's a easy relationship, or you are assuming, you are doing a reasonable assumption that a square is a rectangle, so you inherited it, but it did not work. So here you can see the links of the observation principle makes it clear that the is a relationship is all about behavior. Just because a square is a rectangle does not mean that you can replace all rectangle object with its subclass square, because there are some fundamental differences in their behaviors. So when you inherit and you try to implement this relationship, you have to be careful if the subtype is actually a base type, base class in terms of behavior, not just in an assumption. In order for them to hold, so for the LSP, all subclasses must conform to the behavior that clients expect of the base classes they use. The guarantee of the LSP is that a subclass can always be used wherever its base class is used. So anyway, so these are the principles that you have to maintain. Minimize the accessibility, our composition of our inheritance, program to an interface, not an implementation, the open source principle. Okay, if we conform to these principles, the design will be a good one and robust one. Thank you a lot. Have a good day. Hope